Good day, ladies and gentlemen. This is Sarel van Grenen, aka Mr. VG, and we are in for a bumpy ride today. A bumpy ride, yes. Because this video might be a bit on the long side, so buckle up, gear yourself ready, get yourself ready, because we are going to do some amazing trigonometry. When we look at trigonometry specifically, this is a beautiful bunch of questions, although I have actually spiced them up a little bit when we go through it. So you first try this sum yourself before you carry on and watch the rest of the video. So looking at question 5.1 specifically, whenever I read a question like this, if wada fish paste, determine the value of the following in terms of k. Whenever I read that, I first of all go and draw a triangle that represents cos of 62 degrees, which means cos of 62 is k, or k over 1, which looking from the 62 degrees is adjacent over hypotenuse. Now I want to calculate the missing side using Pythagoras. So our missing side, our y value, is root 1 minus k squared. I don't know whether I'm going to need it. Well, actually in this one I'm not going to, but I'm still going to challenge you with it. Something else that is really awesome if you do it correctly is that the other angle in the triangle is 28 degrees by using interior angles of a triangle. What makes this awesome is I can now straight off answer question 5.1.1 because sine of 28 degrees is opposite over adjacent. So that's just k. Okay. What some of you might have gone, and this is nothing wrong with it, the complementary angle of 28 is 62 degrees. And whenever I see complementary, meaning adding up to 90, I know that sine changes into cos, but this is just k. Potato, potato, tomato, tomato, your choice which one you use. I just love to use my triangle as often as I can. Next up, ladies and gentlemen, I'm now going to look at cos of 242 degrees. When looking at cos of 242 degrees, I'm going to simply reduce my angle, and this is using 180 plus 62 because it's in the third quadrant, and therefore it is negative cos of 62 degrees. And again, cos of 62 degrees is k. So for me, this question is a little bit on the soft side. So I'm going to make life interesting by throwing in tan of negative 422 degrees. Wow! You go and try it yourself first. Whenever I work with these kind of sums, I always have a kind of a checklist I go through. My first question is always, step 1, get my angle between 0 and 360. Step 2, get my angles between 0 and 90. So negative 422, I can add 360 twice, which gives me just tan of 298. If I simplify this, now my angles are between 0 and 360. If I reduce this, I'm going to use 360 minus, because it's in the fourth quadrant, which gives me tan as being negative tan of 62 degrees. And this is where the power of the triangle comes in, because from 62 degrees, I can use opposite over adjacent. So there I have tan of negative 422 degrees in terms of k. They love these questions, And they love to ask it a bit more tricky, like this one I gave you now. Let's look at the next question. Question 5.2. But before I can get to question 5.2, let's just quickly write down our cast diagram. I love to write down the cast diagram because the more times I write it out, the better I remember it. So there I've got my stock standard reduction formulas. Then insert my complementary angles, not compound, complementary angles. In the first quadrant, I work with 90 minus theta. The second quadrant, 90 plus theta. And the fourth quadrant, theta minus 90. Please, ladies and gents, understand, I never, ever, ever at school level use 270 degrees. Not because I can't use it, but simply because it's not in the curriculum. And my students, unfortunately, mess it up when they try to work with 270. So always 90s, that is if I want to use compound angles. Complementary. Why do I keep on going towards compound? Oh man, let's get to the program. Let's look at, first of all, getting my negative angle positive. Now here's a nice little trick. Instead of having to add 360, I can remember that a negative angle is working as if it is in the fourth quadrant. So that sine of negative x in the fourth quadrant, it's negative sine of x. Next up, I'm working with a tan of 360 minus. Well, that's also fourth quadrant, which gives me negative tan x. Then sine of 90. Now the 90 tells me that sine is going to change into cos of x. But 90 plus tells me it's second quadrant and sin is positive there. Forget about what it changes into, sin is positive there. Therefore, I'm now going to take that tan x and I'm going to change it into my identity, which is sin x over cos x. I do that because the coses are going to divide away, the sins are going to divide away, leaving me with negative 1 over negative 1, which is equal to 1. Easy, simple, straightforward. But it all starts with getting my angles between 0 and 360, then getting my angles between 0 and 90. Remember that 90 tells me complementary angles. Yes, I got it right. I didn't say compound again. Complementary angles. But also you've got to look in which quadrant the original one is. The OG, the original gangster. Let's take a look at question 5.3. Now it says there without use of a calculator. Now later on in the video, I'm also going to talk about without use of a calculator. But basically, I'm either going to go towards special angles or towards things dividing away. That's kind of my go-to things for now. So when I look at this, first of all, I'm going to make sure that my angles are between 0 and 360. So I'm going to subtract 360 by the 400, leaving me with sin of 40. Cos in the fourth quadrant is positive. Remember, a negative angle I can look as if it's in the fourth quadrant. Then my top angles are between 0 and 360, but I'm going to reduce them further. So I'm going to take that 130 in the second quadrant, which is going to be negative cos 50. And now sin of 90 automatically is going to change to cos of theta. But in the first quadrant, it is positive because, again, I'm looking at sin in the first quadrant. That gives me positive cos theta. So at the top, I can now start looking at that 50 and say, but how does it fit to the bottom 40? Oh, but they're complementary angles. So I can change the cos 50 into sine 40, which is awesome, because now I've got stuff to do. Because at the top, ladies and gentlemen, I can take out a negative common. By taking out a negative common, oh my goodness, my brackets can divide away, leaving me with -1. Whoa, not that difficult. Not that difficult. So whenever you hear the word without the use of a calculator, remember, you are either going to look for special angles or things are going to divide away. In this case, they divided away because 40 is not a special angle. Let's look at the next question. Evaluate, oh, what a horrible, beautiful, amazingly awful sum. The root of 4 to the power of sine 150 degrees times by 2 to the power of 3 tan 135. Now, most of you, when you see a sum like this, will completely freak out. But it's not really necessary. Because whenever I read without the use of a calculator, I've got 3 things to think about. Either special angles, dividing away, or drawing a diagram. It's always going to be one of those 3. I am pre-warning you. Okay, we love this. But I have steps to follow. So inside my root, I am just going to start by going through my steps, which is number 1, getting my angles between 0 and 360, which they already are. Then going to step 2, which is getting my angles between 0 and 90. So the 150 is in the second quadrant. So that is positive sin of 30. I love it, because sin of 30 is a special angle. That's 30 degrees, tells me special angles. I'm going to repeat this process with a 135, which is 180 minus 45, which is the second quadrant again, and tan is negative there, so negative tan of 45. Another special angle. I'm loving it. So I'm going to use my special angles. So I'm going to say, well, sine of 30 is a half. Tan of 45 is 1. So now I'm actually taking off my trigonometry hat and I'm simply going to look at what if this was an algebra sum with my base being 4s and 2s. I want to get the bases the same. So I'm going to change the 4 into 2 to the 2. I'm going to remove my brackets. 2 times a half is 1. Okay, I skipped a step here. 2 to the 1 times by 2 to the -3 inside a root. So this becomes 2 to the -2, which is 2 to the -2 to the half, which is 2 to the -1 because I'm distributing that in. And I'm left with 1 over 2 to the 1. Oh my goodness. As I said, it's not that difficult. Just following your basic steps. Get your angles between 0 and 360. Get your angles between 0 and 90. Look for special angles. Then the rest is actually just pure algebra. Don't get frightened. Look for your steps. Now let's look at the next question. Consider 4 sin squared x minus 3 equal to 0 for x between 0 and 270 degrees. When we look at answering this question, and how many quadrants can there be? Well, possibly quadrant 1, 2, and 3. Well, we can say this, and it's a 1-mark question, but I am not convinced that this question is this easy to answer, because I must actually look at the actual values of sin squared, okay? So I'm first of all going to try and get sin squared alone. So transposing the 3 or adding the 3 on both sides, then I've got sin squared x being 3 over 4. Taking the square root on both sides leaves me with a plus minus in front of the square root. That is very, very important, which means sin x is plus minus the square root of 3 over 2. Please get this, ladies and gents, that sin now has two possibilities, plus the root of 3 over 2 or minus the root of 3 over 2, which means my reference angle is going to be arc sin of root 3 over 2. You must be able to do this without a calculator. Come on, it's a special angle. It's 60 degrees on the dot. But in which quadrants are this going to lie? Well, it could lie in any of those 4, but remember they said it must be between 0 and 270. So yes, there's going to be in 3 different quadrants, okay? Because of the plus minus. If it was just plus or just minus, it would have made the number of quadrants fewer. So let's quickly now get the values. In quadrant 1, I have 60 plus k times 360. Quadrant 2, I've got 180 minus 60 plus k times 360. Quadrant 3, I've got 180 plus 60 degrees plus k times 360. And what must I not forget? That k is an element of z, because I don't want to add half a revolution or half a period, okay? I want to add full periods. But now we're looking for specific values of x. So I'm going to choose k to be 0. And this gives me my 3 only options, which is 60 degrees, 120 degrees, and 240. Wow, wow, wow. Beautiful trigonometry. I love this. Ladies and gentlemen, please make sure you understand this, because this trigonometry forms the basics of all grade 12 trig you're going to do. It's just going to become a lot more complex. You can ask your matric mates. Oh, trigonometry in grade 12 becomes a beautiful beast. So please make sure you've got your steps for grade 11 down, so that when you get to grade 12, you are covered. Ladies and gents, have a beautiful day. Enjoy it. Keep well and stay safe. This is Mr. VG signing out. Cheers.